Mr. Gill's revision egg.
Okay, lesson number 7 of the wonderful egg-based A-level biology lessons. We've neglected the shell so far, but the shell, as well as being a semi-permeable membrane from lesson number 1, is also made of an interesting substance. It's made of calcium carbonate predominantly. It is quite membrane rich. What you can actually see in here, right, and this bit here is a little membrane holding what's called the air pocket, which is a structure you'll find in most eggs. If you ever hard boil an egg and it's got a dip in the end, that's the little air pouch that's in the egg. You can see that there, and that's held in by a little membrane. Okay, we're not interested in that though. We're interested in one of the minerals that makes the egg hard, and that of course is calcium carbonate. Now calcium carbonate is a base, right? It neutralizes acids, and that's what we want to talk about in this lesson 7, right? Which is acids and alkalis, because you are expected to have a basic understanding of how pH and neutralization works. So what I'm going to do, I'm going to grind up the eggshell to extract some of that calcium carbonate, right, to make that into a powder. And I'm going to show you a simple neutralization reaction, talk you through the chemistry of what's going on. Okay, so that ought to do it. Right, some lovely eggshell powder there. Right, I need an acid. Now, fortunately, your house is full of acids. This is just cheap distilled vinegar. Can be used for cooking or cleaning. I'm going to pop this in this little glass here. Now, I'm sure you've seen neutralization reactions before. We want to see the bubbles because, of course, this isn't probably the most dramatic one you're going to see because the concentrations aren't high enough. But I'm going to put a little bit of fairy liquid in there to try and hang on to some of those bubbles that we're going to manufacture. I'm going to give that a stir. Lovely. I'll move this in nice and close to the close-up camera. And pop in on the top some of our ground up eggshell. And you should start to see a bit of a fizz. There we go. Not the most dramatic chemistry demonstration you've ever seen, but it does show you that there is neutralization taking place in there. There's fizzing. That gas, of course, is carbon dioxide. I'll show you the equation here. All right, if it comes over the top, so be it. So that there is our neutralization reaction. Now, for an A-level perspective, you are expected to know what's going on there. So pH is essentially a measure of the partial pressure or concentration of hydrogen ions, okay? And nobody understands this the first time they hear it. But when you have those pH numbers, pH 1 through to 14, what you're actually talking about is you're talking about the negative of the log to base 10 of the concentration of hydrogen ions, okay? So that is obviously a confusing sentence. I'll put up a picture which illustrates that. What it means, simple terms, is that every pH number you move, so pH 1 has got a huge number of hydrogen ions free in solution, okay, and pH 14 much less so. And as you go between pH 1 to pH 2, you've got 10 times less, 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 okay? Now, to be even more specific, it's not just the amount of hydrogen ions that are there, it's the amount of free hydrogen ions. Because in a neutralization reaction, what you'll have chemistry going on where hydrogen ions are either generated or rather removed from the acid. And that's to do with OH groups. So OH groups have a negative charge on them, hydrogen ions have got a positive charge on them. When they attach together, the hydrogen ion is taken out of solution and no longer contributes to the pH. Okay? Now, this takes a little bit of thinking about, a little bit to get your head round, so I suggest you go away and have a look at exactly concentrations of pH, right, the concentration of hydrogen in pH numbers related to those pH numbers themselves, and try and get your head around why pH works the way that it does, okay? But that is an illustration that you can do with a simple eggshell to show a very simple neutralization reaction, and that is lesson 7.
Mr. Gill's revision egg.